You're muted. Can you unmute yourself?
Hello, am I audible?
Yeah, we can hear you. Please start.
A very good afternoon to everyone present here. So our topic is spatiotemporal air pollution concentration. And we are a group of 4, Apurva, Neha, Shreya, and myself, Juhi. Apurva, can you skip to the next slide, please? Okay, so as we all know, air pollution is a major environmental issue which is affecting many countries worldwide. The World Health Organization estimates that 9 out of 10 people breathe air that exceeds safe limits for pollution, and about 7 million deaths occur annually due to this. Predicting the concentration of air pollutants is an effective method for preventing the pollution incidents by providing an early warning of harmful substances in the air. So, what exactly is spatiotemporal? Spatial is nothing but space, and temporal refers to time. Air pollution is a regional problem that causes a spatial dimension consideration. This means that there is a spatial correlation about air pollution among neighboring cities. It also requires an assessment of the quality of air to time.
So, our objective is to comprehensively review and analyze various approaches uh, used in predicting air quality. This research involves assessing statistical, machine learning, deep learning, and hybrid models, aiming to understand their efficacy, limitations, and adaptability across different spatio-temporal context. Apurva, next slide. So our research paper is a comprehensive overview of 4 different methodologies, namely statistical, machine learning, deep learning, and hybrid in the prediction of air quality pollutant concentration. Each category was defined based on various research papers, including primary models and algorithms followed by the strengths and weaknesses of each methodology. The goal of this paper is to provide a concise yet informative glimpse into the characteristics and trade-offs associated with each modeling category.
Takeaways from the research. Our survey of spatiotemporal air pollutant concentration prediction model reveals the significant insights. The statistical models exhibit interpretability but lack in capturing complex, nonlinear relationships. Machine learning methods showcase promise in handling nonlinear patterns but might require careful hyperparameter tuning. Deep learning models excel in capturing intricate spatiotemporal dependencies but demand substantial data and computational resources. Hybrid models combine strengths and show potential integration complexities.
The methodology we will be using to implement is a spatio-temporal fusion of ResNet, or residual neural network, and a convolutional long short-term memory-based model. So the ResNet is used to deeply extract the spatial distribution features of pollutant concentration, and the output of this particular model is fed as an input to the convolutional LSTM, which further extracts preliminary spatial distribution features and extracts spatio-temporal features of pollutant concentration meteorological data. So this is the architecture we will be using to proceed for our model. So initially the data is cleaned and processed. Then we select the important features that we will be requiring. This process data is fed to the models, ResNet model, and the convolutional LSTM, hence ultimately creating the spatiotemporal air pollution prediction model, which predicts the PM 2.5 concentration of a targeted city. Thank you.
I'm K. Nagmahalakshmi. I'm a research scholar at SR University, Warangal. And I'm also working as an assistant professor in Engineering College in Hyderabad. So I would like to present a review paper on integrated deep learning in urban traffic management, which is a comprehensive review of pedestrian behavioral analysis and trajectory prediction at crossings. Actually, in today's, like in the future, let me go with the with the growing number of intelligent autonomous systems in human environments, the autonomous systems which are able to perceive, understand, and anticipate human behavior is becoming increasingly important, right? So, and even predicting future locations of dynamic agents and planning the considering such predictions are very critical tasks for self-driving vehicles mostly, and in advanced surveillance systems, which is very important for us to do the lot of research. And my main focus is on autonomous driving, which is an active area of research, and it includes many issues related to navigation and trajectory prediction. Now, that means what is in the if an autonomous vehicles want to drive, we need to have a collision free navigation, and we need to have accurate trajectory prediction capabilities. Now, what do we mean by predictory prediction is it is a problem of predicting the short term and long term spatial coordinates of various road agents like a car, a bus, a pedestrian, a rickshaw, or animals, etc. So, because every particular object will have a different dynamic behavior, right? A person may behave aggressively and drive the car or something, or an object suddenly, a car or a particular animal comes suddenly. But for the autonomous vehicles, it is very difficult for them to identify the behavior of that. But if it is coming to the human, it is different. We can analyze the behavior of the animal, or we can analyze the behavior of the person, how he is crossing. But it is difficult for an autonomous vehicle to calculate that. That is a promising area where we can do the lot of scope in challenge. These are the challenging areas. So the autonomous cars like driving in an urban environments are challenging because they should be able to communicate with other road users and understand their intentions. So such interactions between are very essential between cars and pedestrians, as the most vulnerable road users will be there. So, however, this understanding of pedestrian behavior is not that much intuitive, and also it depends upon the demographics of pedestrians, traffic dynamics, environmental conditions, and etc. So my paper is focused on proposing a unified deep learning approach for pedestrian behavior learning and its trajectory prediction. So my challenge is to have autonomous vehicles. If we like, a lot of autonomous vehicles are also going to come on the roads. So for the autonomous vehicles, providing a safe interaction with the pedestrians, and especially in uncontrolled mid-loss walks, because there's a lot of crowd. Like if it is a normal environment wherein there is no traffic, it's fine. But when it is having lot of crowd, and identifying, giving a safe environment to that particular autonomous vehicle, identifying the and driving in a safe way is a very critical challenge. That is the reason we need to concentrate mostly on the pedestrian trajectory for safe motion planning. So short-term trajectory plans may be sufficient for collision avoidance at low vehicle speeds. If a vehicle is at a low speed, short-term trajectory predictions are fine. But at higher speeds, it should be able to analyze the pedestrian trajectories over long durations itself. So that is one of the challenge which we face. So, but however, for safe and efficient operation on roads, autonomous vehicles should not only understand the current state of the nearby road users, but also one more important aspect what we need to consider here is the future behavior object detection is also important, and the behavior of the predictor, that is a person, are the main important factors that we need to consider for the perception system of the autonomous vehicle, right? And for this, behavior prediction plays a very key role, and trajectory prediction is also great importance for a wide range of location-based applications in this intelligent transport systems, like route planning, traffic management, and early warning systems. So this is my paper mostly centers on autonomous vehicles and their development, and the main focus is on machine learning applications for motion prediction and behavior analysis of surrounding agents. Right, the goal is to mention the importance of creating autonomous driving system with enhanced safety, to incorporate a model in the autonomous driving system with enhanced safety, efficiency, and interaction with human pedestrians and other road users. And for this, we have to handle mixed traffic conditions and urban environments, right? And one main important aspect is in the image processing, we do this. So in the image processing, generally we go with the concentration of the images, but we never consider the emotions, emotional classification. But how come the emotions and images will be mingled with together? It's a different aspect. It is not related to emotion or facial recognition, but we are going to combine emotion based on the person's mood. Maybe if some person is like sad, some person is happy, some how he will stand. The image pictures or the posters based on that, we are going to incorporate a model whether the person will suddenly cross the road or he may not cross the road. Like that, analyzation will be done, and a safe model so that the autonomous vehicle can understand based on its images, the posters, that person can the vehicle can analyze and he can stop or something. So there are many cases where we can do this. So this is just basic introduction about the paper. And when it comes to the background, I'm not going into detail it as the time constraint is there, but I can tell you the main things. Like the data collection from a moving object, the data collection is a bit different. As further, we need to go with the data mining tasks. Like we need to go with data pre-processing has to be done, data management has to be done, query processing has to be done, and data mining tasks also has to be done. So the main data mining tasks which will be done are classification, clustering, pattern mining, and knowledge discovery. This is related to data collection. And trajectory data clustering is mostly important in this particular area, wherein if we want to concentrate on the autonomous vehicles. And the most important thing what I want to concentrate is in the literature review. Like first, my main literature review is on trajectory prediction, road agent behavior prediction. So pedestrian tracking is all pedestrian tracking with motion models. This is a literature review I have done because this is the essential task for semantic understanding of a particular video. Like pedestrian destination, predicting their motions, how the person is moving, like how he will be, how he is standing on the path, whether he will cross suddenly or not. So that is the most important thing what we need to consider so that no accidents happen. A pedestrian tracking algorithm will be used as an agent based behavioral model. So these are the marks. These methods are slow and mostly they work offline, but they will not be working with heterogeneous crowds. If it is a small, like a normal, very small distance, it's fine. Now, in the and the other thing which I've concentrated on the literature review is pedestrian path prediction, and as well as pedestrian behaviors and the crowd density. Based on this, the literature review have come up with a unified deep learning approach. See, their deep learning networks are used to model pedestrian behaviors, but the challenge is pedestrian walking information as the input, right? So when it comes to the issue, the conflict, like a very important thing is deep CNNs have shown impressive performance in some tasks like movements like segmentation, behavior detection, crowd scene awareness. These are all not detected. Like pedestrian modeling is not developed still since now in the deep learning. But so the motivation is to create the autonomous vehicles have a clear understanding of their surroundings, allow them to predict other road users' intentions and actions also. So these are the limitation. Now the existing methods are there. There are trajectory prediction method, the behavior modeling and interactions are there. Road agent behavior predictions. These all are there. Wherein pedestrian behavior, for this we can take these pedestrian factors like social factors, gender, age, social norms, state, characteristics. These all will come into the picture. But age, because if age elderly person is driving, he'll be driving in a different way. If a young person is driving, he'll be driving in a different way. So these are all things we have to consider. But the most important thing is emotion classification from pedestrian motion is the most important thing. Now, the recent research in computer vision AI has primarily focused on emotion identification from facial expression. For example, if a person is sad, suddenly he may come in the road. Like he will be standing in a different posture. How we are going to analyze the images? Suddenly he'll be standing in a different pose and suddenly he jumps into the road. And the autonomous vehicle cannot detect. Suddenly the accident may happen. That is the reason. So based on that, like based on his different emotions, the image poster will be different. The person standing or will be, the posture will be different. Based on that, the image processing, we can identify that the person will cross the road or he may not cross the road. Short distance and the autonomous vehicle, if it's coming very fast, it will be very hard for it to identify that. So that is the reason we have the most concentration in on emotion classification from the pedestrian motion. This is what is in. So, for example, you can see here the postures are there. If this person is angry, he may be in one particular pose. Sad, he may be in one other pose. Happy, he may be in another pose. So, based on the images things, we have some different models, to develop new motion models, and combine those behavioral models using real-time tracking with deep learning and motion models, and combining these together will give a better dynamics using Bayesian interfaces and handling the dense crowds. So these are the proposed models, rule-based behavior models, like and if we a simple example I can give you is here is, suppose the car is, if a traffic red light comes, it should slow down from the specific distance itself, whether our cars in the front of it or this one. So these all models need some rules or heuristic approaches. Now these all models, if we implement it, and in the autonomous, like we have another models also, like if the some cars suddenly they want to take a left turn or a right turn or somewhere, suddenly the autonomous vehicle cannot identify it. So in order to understand that the behavior of the vehicles also, the pedestrian behavior also, we have different kind of models. These are the future proposed models: data driven behavior models, rule based behavior models, and the traffic flow models. How the based on the traffic flow models, we can go. So based on the peak hours, how the traffic will be, how the jams will be, how to overtake those, all these things. These are the my proposed models which we can implement, and in the autonomous vehicles, we can incorporate a model such that no road accidents take place, and the cost effective cars can be used in urban areas. So this is from my end. Thank you.